Hello everyone, welcome back. Today I came with one more interesting topic in Java called how linked hash map works internally. So in last video I already explained about how hash map works internally. So if you did not watch that video, you will get some clarity on how hash map works internally, then start learning how linked hash map works internally. So if we can understand HashMap internal working mechanism, then it is very easy to understand linked HashMap working. I mean internal working of linked HashMap. So when you are trying to create HashMap, so it will create array of 16 buckets. So each bucket holds default value is null for the class node. So when you are trying to put key and value, first it will calculate the hash for key. By using that hash, it will find the index, then corresponding index it will store, it will create a node with four properties like hash, key, value and link to the next node. So if more than one node, more than one entry get the same index, in that case, it will maintain the linked list. So in the form of linked list, it will attach that new node to previously created at end of previously created node like this. So and moreover that at the time of getting, when you are trying to pass key, right? So again same process. It will calculate the hash code for key. By using that hash, it will find the index, then it will go to corresponding index. Then first it will compare the hash code, then it will compare the equals method. So if it is matched, both conditions matched, then only it will return the value. And moreover that special case, there may be a chance of more than one object having same hash code, right? So if two objects having same hash code, first they will check hash code hash code equals by using double equal to operator along with and logical and key comparison by using equals method. So if both matched, then only it will return the corresponding value. So this is also I explained in detail. So if you did not watch that video how hash map works internally, then start learning how linked hash map works internally. So hash map and linked hash map almost similar except one difference. So in HashMap, we can't predict the order, but in linked HashMap, we can predict the order. That is the major difference. And along with that, here in class we have four properties, right? In linked HashMap, we have class called entry. So along with these four properties, we have two more properties, that is before and after. Let me try to explain about internal working of linked HashMap. So we have class called entry also static class like node class entry, so that extends hashmap node. I will show you the documentation. So hashmap dot node, why? Because node is the static class, right? That's why we are trying to use by using class name dot node. So like this it will inherit all four properties. Let me try to list write down. Anyway, it is already inherited once you make extents, right? So anyway, let me try to list out them. So int hash, next one is key, next one is value, next one is node of key comma value, link to the next node. Along with these are from parent, that is node static class. Along with these four, we have two more, that is this entry itself, entry of key comma value before, and one more entry key value after. These are the two extra properties that exist inside entry. Now let me try to show you the documentation about linked hash map. So under map, linked hash map, let me open the documentation about linked hash map. Linked hash map is child of hash map. Let me try to show you that. So if you can observe here, linked hash map extends hash map. So linked hash map is child of hash map. So and moreover that I need to show entry. So entry is the static class, extends hash map dot node. By default, all these four properties available: hash, key, value, and next. So along with these, here you are seeing, right, before, after. So that's what I am trying to declare here. Now when you are trying to create linked hash map also, it will create array of 16 buckets, same as it is, whatever it may be applicable for hash map, it will also create array of 16 buckets. Let me try to create them. So we try to write properly straight line. So imagine this is the array of 16 buckets. So let me try to divide them. So like this we have, imagine 15 buckets are there. So we can, anyway, for understanding purpose, I can write here 15. So anyway, 0 to 15. Here you can imagine. Let me try to little bit down. One more bucket I will add. So here and here. Finally, I will add 15 here. Imagine this is the 15 bucket, last bucket. So this is the 0th bucket, right? Like this it will create. So here also default value will be null. All default values it will store. By default it will be null. So 0th bucket null, first bucket null, null. All values will be by default null. Here you can imagine from 0, 1, 2, 3, 4, 5, 6. So here anyway 6 to 15 bucket. Now let me try to explain about internal working. So when you are trying to put, so it will find the again same process. It will find the hash code for key. By using that key, it will find the index. Along with that, keep in mind it have two special properties before and after. Along with that, two more will be there. Like here we have concept called head and tail. Previously, there is no concept like head and tail. I mean in HashMap there is no concept like head and tail. There is no concept like this, but in linked hash map we have that concept. So imagine if you are trying to create one object. So let me try to imagine I created object linked hash map. So linked hash map dot put some key string and value is 1, something like that I am trying to put. Now imagine I got the hash code per key is some xy, some 298,261. By using this I got the index is 1. In that case, let me try to remove null. Now I got the index, right? So it will create one index, one node that is having 5 properties along with key value. So first one is before, key, value, hash, next, before. Now let me try to write them. So before, imagine this is the before, key, value, hash, next, after. 5 properties, right? So it will maintain like this. Anyway, here you can observe that key is a and value is on, hash code is something 98261, like that. Before is anyway, before any we don't have before, right? By default it will be null. After also by default it will be null, like this. Now let me try to explain internal working. So if I can create node like this at initial, when I am trying to create first node, so first node becomes head node. We try to take red color. So this node becomes the head node. So we have concept like head and tail, right? So first node becomes head in this case. So I can make it as a head. First node, whatever node if you are trying to add, that is the head node. And before that head node is, there is no before, right? In that case, before is null. So and moreover that tail also become first node itself, tail. So this is first node itself head, first node itself tail, and there is no before, there is no after, and there is no next also, like this. This is the first insertion. So imagine if you are trying to create one more node, one more object. Imagine that object also got first index. when you are trying to calculate key, I mean hash code for key, by using that hash code you get the index, right? Again I am getting the same index, I mean 1. So imagine, so in that case it will create one more node. So one more node with along all these 5 properties. First one is before, key, value, hash, next and after. So now this tail will be removed and this tail will be pointed to whatever node we recently added. This tail will, I mean, keep on moving. So in that case, now we have concept called before and after next. So after of first node is this node and before of this node is this node. So in that case order also we need to track, right? This is the first node. So for understanding purpose I'm putting some numbers here. So this is the second node and we have next, right? That next will be linked to here. If we can observe, this next will be linked to here. So let me try to write that corresponding values before, key, value, hash, next, after. Now after is null. So before of this second node will be first node after, first node after is second node before. Like this it will maintain the link. So imagine one more node we got the same index. In that case also it will maintain same 5 properties before, key, value, hash, after, next. So before, key, value, hash, next, after. So now the tail also again will tail move to third node. Tail always update when you are trying to insert new value. Tail will always update. Now the tail is third node. So let me try to update here. This is the third node and after of second node is third node, before of third node is second node. And this link also, no, this node next will be something. Let me try to move the link here. So here I can remove, I will update again. So this link will goes to here. Let me try to write properly here. Now this is the tail node. So if you can observe, for maintaining link they are using that before and after. Moreover that if you can iterate once you end, again you can backward also it is possible. So this is internally working like doubly linked list. So imagine next time I am trying to add, I got the index at 6. So in that case how it will behave, let me try to write. So I got the, when I am trying to put fourth value, I mean fourth entry inside that linked hash map, it got the index at 6 inside that bucket. So before, key, value, hash, next and after. So before, key, value, hash, next, after. So I'm making some characters here, but anyway in real time at the time of putting you can put values, right? So if you can understand the concept, this is almost similar to hash map only. So once we got, this is the fourth index, right? I mean fourth node, this is third node. Now again tail will be removed, tail will be recent node. Then now the link will be third after is, if we can observe, third after is here, right? So before it will be null. Now we have, right? So in that case it will come like this. Let me try to write some link here. It will maintain internally like this. It comes to here. Now third node after is fourth node, fourth node before is third node, and anyway after of fourth node is there is no node null, right? So here next also, for I mean third node next is, if we can observe, third node next is fourth node. Will point into like this. So if we can get one more node at sixth index, it will maintain again linked list. Key, I mean before, after, I mean key, value, hash, next and after. So now same process. Fourth node anyway here tail come to here, right? So here it is tail. Now the tail here also move to fifth node. Here this is the tail node. Now fourth node after is fifth node before is fourth node. So now this is the fifth node. Before key value hash next after. After is anyway null, like this it will maintain link. Now if we can observe that there is a link right from 1 to 5, that's why we can predict the order. So this is the head node and this is the tail node. Even though if you have 100 nodes, every node have link from one to another. Whereas in hash map, so at one index entries on one index linked list, sixth index in linked list, there is no link, right? That's why we can't predict the order. But here every node have link from here to even though in one index we have three, in sixth index we have two. Even though if we have two, three, four index also, there may be a link. Without link, it is not possible. So I mean, it is not possible to predict the order. Now when I am trying to access, I mean, imagine this is the linked hash map, right? Linked map dot entry set. How we can access the elements from map? By using entry set only, right? Entry set, entry set. Now the entry set will return head node. So once I have head node link in my hand, then I can move right forward. So one by one, one by one. So it will start from one until unless it reaches to tail. So anyway we have link at tail, right? Tail also, right? If you want to reverse in reverse order, by using tail you can move backward, by using head you can move forward, both it is possible. Internally it is working like a doubly linked list. Now if we have pointer at head node, move forward one by one, one by one. That's why insertion order is we can predict here. Now let me try to write example inside IDE. So if I can write here, I mean, linked hash map key is string and the value is integer, right? So linked hash map dot put, I'm trying to provide key is Java and value is some 12, some random integer I'm trying to pass. Let me try to duplicate it, then I will update it. So two more, I mean, I copied, I mean, 5 times. So Java JDBC and 11 15. Let me try to update keys as well. So I'm trying to provide spring. Next one is spring boot, and value is 9. So like this, any number of values also I can j2 double e, some value is 2, and I can say jpa, I can provide value as 3. Now if I can access the elements by using either it may be enhanced for loop or by using for each method that was introduced in 1.8, right? Let me try to show you that. So first I need to apply entry set, right? So linked hash map dot entry set, then I will apply for each. So from that for each method is expecting consumer, right? So by using that consumer I can access the, I mean, I can print the elements both key and value. So e dot, from that entry we can access the key value, and I'm trying to make some separator here for key and value. So again e dot get value, get value. If I can run, I can predict the order. So first it will be Java JDBC spring spring boot j2e jpa. Let me try to run. So I am expecting same order, whatever order I inserted, same order I am getting. So this is called linked hash map work. So if I can run in hash map, I can't predict the order. If you can observe, I can comment it out all. So I can comment it out remaining whatever I explained at the time of hash map. I'm trying to comment it out. Let me try to copy this logic. So I can reuse here in hash map. So anyway, I can remove this. This one also I can make a comment. So remove this one as well. So now let me try to apply. So m dot interset. Now if I can run, I won't get the order. Anyway, here this is the duplicate objects, right? One some and so I am making unique values. I mean unique keys 326252. Anyway, again it is unique. Now if I can run, I can't predict the order. Let me try to run. So first I insert Varun, right, but I got Tarun. So then at last I entered Naveen. So Karun is, I mean, zigzag order, right? Behavior of hash map, we can't predict the order, but we can run here. We are predicting the order. So whatever data I entered, same order I am trying to get the values. So this is about internal working of linked hash map. So we have some extra method, add, put, and I mean put at end, put at last. Some methods will be there. Let me try to show you that. So put last, put first, yeah, here put first, put last. In that case, so if you want to add like this, put first once, anyway, whenever you are trying to put at the initial time, only one node will be there, right? I mean there is no nodes, right? In that case, first node becomes head and first node becomes last. Wherever it can be inside within that 16 range. I mean array of 16 buckets, right? Within that 16 range, it can insert at anywhere. So once you insert at least one node, then this will be apply. I mean put first, put last. So the one node is already exist, put first you can apply, then first node will becomes to tail. Whatever you node updated recently, that becomes head. That is about put first. Put last means anyway we are right now I am applying, right? Similar. Once you apply the any one node, then it will keep on tracking at the end. So that is about put last. These kind of some methods will be there if we have time. So dig in inside it. I mean what is the purpose of that put first, put last, along with that put first and put last. Anyway, entry set we can use to access the elements. So we can override default initial capacity with loading factor, contains value. Anyway, it is extends hash map, right? All properties that exist inside a hash map by default are available in linked hash map. Why? Because it is child class. So I hope you got some clarity how hash map, I mean how linked hash map works internally. So let me try to conclude. So linked hash map also almost similar to hash map, except one difference. That is, in linked hash map we can predict the order. In hash map we can't predict the order. Enough. That is the main difference. Then along with that, there is a concept called head and tail in linked hash map, and moreover that it will maintain the data two more extra nodes. I mean entries here in this case. It will take some extra memory comparing with hash map. Why? Because this again it will consume some extra memory, right? That is also one important point you need to remember. I already make some notes about that linked hash map here, if you can observe. So internal data structure is combination of hash table and linked list. So anyway, that array of 16 buckets, so we can call it as a hash table and linked list. So null values allowed only one null key. Anyway, hash map also allowed only one null key. Ordering maintains the insertion order. This is the main important point about linked hash map. So duplicate keys. So it can allows only one duplicate key, does not allow duplicate keys. So it will means does not allow means whatever you don't get any compilation error. So last one will be overridden to previous one. If I can copy, so here I have two JPS, right? If I can run, I got only one JPA. I did not get any compilation error, but this one will be, if I can update that value, then you will get more clarity. So now I will get JPA with 90, not JPA with 3. So JPA with 90. Now you got the proof, right? Previous one will be overridden by recent one. That's what duplicate keys does not allow. Last one will be overridden by previous one. So thread safety, it is not thread safe. We will get concurrent modification exception. Performance slower than hash map. Why? Because additionally overhead maintaining the link, right? So if you can observe, this is the big headache. So three links we are maintaining, right? I mean along with before, Here we have before, after, next. There may be this kind of link headache. It will take time to traverse. So that's what it is saying. Some performance is somewhat lower than, it will take some high, time complexity will be high comparing to HashMap. So fail fast iterate. It may be through concurrent modification exception and example use case. So best example for linked HashMap is to implement LRU cache. LRU stands for last recently used. So that is about linked HashMap. Some important points you need to remember. So I hope you got some clarity about linked HashMap, how internally it will work. So if you like the content, hit on like button and subscribe Programming KT. Thanks for watching.